we're back. So there was probably an awkward pause here. That's just because we had to stop shooting for a while. But we're back, and we're talking about when these functions are reversible. Um, so we looked at several. Some are reversible, some are not. We need to answer a question and lay down some rules when they are reversible. So let's look at an example. So here we have one, y equal x plus 6. Perfect example of a linear function, which we're going to draw out right here. And just looking at the graph there, we see, well, for every input I pick, 1, 2, 3, 4, 5, 6, whatever we decide to pick, there's one and only one output. And that's pretty evident from this graph. So this one clearly is reversible. So linear, reversible. Let's look at some other ones.
Can I make a quick comment?
Yes, you can.
Yeah, and kind of along with that, you have to make sure that you're looking both at the mapping going to the x-axis, but you also have to think about the mapping going to the y-axis. So, like the black lines kind of indicates a function. The purple lines kind of indicate that it's a reversible function. So we should be able to pick out a single y value, like this one right here, and then trace it back, hit the line to come down to the x value. Like same example right here, like pick this x value, trace it to the line, kick it over to the axis. So this should only result in one y value. Sorry, I went backwards. Sorry, the y value, kick it to the line up to the x-axis. So it should only result in one x value for any y you choose. So reversible, you better believe it. Here's a little happy face for you. Mr. Martin?
All right, so example of one it is. Let's look at one it's not. So 0.5x squared, definitely going to be a parabola. Be a little bit probably different of a parabola than we're used to seeing, but let's take a look at that one.
We've made a teacher quit.
Yep, she's done. So, but anyways, let's look at this graph.
Yeah, parabola.
Nice parabola.
That's not a good parabola. I'm going to do it.
So we'll let Mr. Collins redo this one, so we have a nice looking parabola.
Let's go with it.
All right.
Let's go with it.
That one is marginally better, but we'll go with it. So this one, we know it's a function. But again, the question is reversible. So if I pick any y, can I predict an x? So let's look at that. Let's look at y equal to 5. We'll just pick that one out, and we'll pretend it's y equal to 5. So we'll draw a line straight through 5, because that's our outputs. We want to look at our outputs there. And it also happens to be a horizontal line. So y equal to 5, it occurs, it looks like, at 2 points, which implies that, well, there's an x there for y equal to 5, and there's also an x on the other side in the negative quadrant, or second quadrant, negative x. This also has the same output of 5. So this one definitely not reversible. So we have two examples. I think we're starting to drive towards a pattern, but we might not be there quite yet. But here's another one. It's also be in a parabola, a slightly different parabola. Again, we look for any y value that we pick. It's going to occur at two different x values or two different input values. This one will also not be reversible. For instance, y equal to 2. It's going to occur at two different x values, and you can confirm that with the graph here. Definitely not reversible.
Oh, wait. No.
There we go. Definitely not reversible. So last one, we're going to look at f of x equal to square root of x. This one, some of us might have to think about how this one's made. It's probably been a while since we dealt with this one. But it's just kind of a curved, non-constant line. For any x I pick, for instance, x equal to 4, I can figure, well, there's only one output for x equal to 4. And I can find that by taking the square root of 4, which corresponds to y equal to 2. So again, for any input, there's only one output. For every output, there's only one input. So definitely reversible. So now we looked at a few examples. We kind of needed to come up with a rule to say, well, functions are reversible when. And it happens from what we've seen with these graphs, that if there is, for every input, only one output, then we know it's a function. That's well, not necessarily it's reversible. It is a function, but if there's only one input going to, or for every one output, there's only one input, or in this case 1 to 1, then it is reversible. So I'll say that again. If for every output, only one input goes to that one, then it is reversible. For instance, if we looked at y equal x squared, we know that for an output of 2, there's two possibilities, two x possibilities. So to sum it up, for every one output, or for every output, there's only one input, or only one input maps to it. So that's when they're reversible.
Yeah, and I think we saw that kind of play out in the grass. And just so, anytime we had kind of, here we go. Anytime we kind of had a single line where it didn't kind of curve back on itself, and that's a very rudimentary way to say it, but it's an accurate way. So like we had this going kind of omnidirectional, one directional. It didn't kind of reverse itself and become symmetric. It became a reversible graph. Here we have symmetry, left-right symmetry. It kind of curved back on itself. That's going to be a non-reversible. Oh, hello. Okay, curve back on itself, non-reversible. Didn't curve back on itself, reversible. So this idea that each output only being mapped by a single input is important. So what then would we make of? Whoa, there it is. What do we make of the sine graph? So this is y equals sine of x. So we've been driving towards trig. This is about trigonometry. So the natural question to ask is, well, is a sine function reversible? So in other words, if we accept like y equals sine of x to be translated into the ratio O over h is equal to the sine of theta, then is it true that if I give you a theta, you should be able to predict a ratio? Well, knowing what we just talked about, where are you, line? There you are. Given what we just talked about, it seems like the answer to that is going to be no. Because here we see for a single y value, I have already two different angle values that are going to map it. And if you really kind of consider like what happens after 360, knowing it's periodic, knowing that's going to keep on going, I can't drop, but it's going to keep going the same wave, repeat over and over, it seems like there's going to be literally an infinite number of ray values, angle values, that we can track to a single over h ratio for y. So the initial reaction is that this isn't reversible. Okay? So here's the bomb. Here's the truth. Ready? It is. You can actually predict a ratio of side lengths given an angle. So hold the phone. How is this possible? Well, to give you kind of a hint, get you guys ready for Monday, what we're going to do is kind of look at something that isn't this function. We're going to look at a quadratic. So the kind of key word for this is practical. So let me explain what I mean. Let me create some axes first. So I'm going to graph an equation for a situation. I'll use one that's familiar, something from algebra. Let's say I'm standing atop a 1, 2, 3, 4, 5, 6, 7, 8, 9, a 9-foot platform, and then I just take a rock and I just drop it. Well, the equation that's going to map the height will be h of t is equal to negative 16t squared because of gravity. No initial velocity, and then just plus 9 because, well, I'm 9 feet off the ground. If I were to graph that function, I'm going to try another shot at this graph and parabola thing. So if I'm going to graph that function, look at that. Yeah. That's going to be what the function looks like, more or less, where you're going to have the time mapped on this axis, and you're going to have the height. It's going to be right sideways. Yeah. Height mapped on this axis. So if I were to ask you the same two questions about this, one, is it a function? Well, obviously, yes, it's a function. We can see that by kind of using that bad choice. We can see that by looking at kind of that vertical mapping. You can never see more than one intersection point at a time. So it definitely is a function. Now the next natural question would be, well, is it reversible? And based on what we talked about, the answer should be no to this, right? Because like right here at like was it 6, 7, 8, 9? So at 6 we see two distinct values for x. Here at 1 we see two distinct values for x. So immediately we should be able to say that we can't predict a time given a height. So here's where the word practical comes into play. We shouldn't consider the entire function. Like for this situation, which is a rock being dropped off a platform, negative time doesn't make any sense. Like anything this side, whoa, come here, shade. Anything here over to the left does not make sense to actually talk about because, well, up until this point in time, the rock is in my hand, just standing there. So in essence, like this symmetric part of this parabola doesn't exist for us. So I would say it should not be reversible, but it is reversible given only the practical domain.
Mr. Collins, I think that is a great way to say it. Talking about practicality. So when we're doing math, we're doing geometry, it needs to be practical. We don't do this just for the heck of it. We're doing it for something practical, and that's what we're driving towards. So think about that. Think about practicality as you watch this video, after you watch this video, before Monday. Because that's going to give you a heads up, give you a step up on everyone else who didn't take the time to think about that. So yeah, just be ready to discuss that. Be ready to talk about practicality. Be ready to talk about sign, and when sign happens to be reversible, because we already made the claim that it is. We've given you half the answer. Just figure out where it is and why it is. So
I think it'd be worth it at this point then, if you were kind of struggling for what you can comment on in this video, why don't you try to answer this question? When is the sine cosine function practical? Okay, so if we're saying it could be reversible over a practical domain, when is sine and cosine possibly practicable? So why don't you take that, comment on that on the YouTube comments and Moto comments, start that discussion. So, Mr. Martin, do you have anything else?
I think we're good.
Okay, so this is Mr. Collins and
Mr. Martin.
signing off. So thank you for watching this. Remember, it is a quiz. Great to do this. So hey, why not help yourselves out and watch a little video over the weekend and get a quiz grade? Hey. Yep. Have a good weekend, guys. See you Monday.